on it, and we're supposed to figure out the real power being absorbed by the 1 ohm resistor on the right. So basically our 1 ohm resistor over here is the load we're looking at. And I was not able to cut and paste it without getting that little thing there. So this is determine the real power being absorbed by the 1 ohm resistor on the right. Okay, so as usual, the way I'm going to do this is to figure out the complex power and then get the real power out of that. So let's see how we might go about doing that. We've got a current source, we've got a voltage source, we've got an inductor, and we've got a resistor. Is this the one I made? Yes. Yeah, that's the one I made. Okay. So I would like to get, I want to find S equals 1/2 VI conjugate. So I would like to get the voltage right here. So I'm going to do my favorite, some nodal analysis. So I'll have V1 and I'll have VL over there, and I'll make this ground. And so for V1, my nodal equation will be V1 minus 4 over J100 plus V1 minus VL over 1. I don't know why I have 2 microfarads in there, and the inductor has already been changed, but the 2 microfarads have not. So we need to change those 2 microfarads to a phasor. So oh, wait a minute. I don't need to find the voltage because I'm given the voltage was hiding underneath the recording controls. Yeah. Okay, so I don't need to find it. Hopefully, there was a mention of a type of error earlier, and hopefully that this problem does not have that type of error, and if we were to find the voltage, we would find that it would be 3.26 angle 150, but we're just going to say that is what we have. So the voltage across the resistor is given to us. So VO, if I write it as a phasor, is 3.6 angle 150 degrees. So in that case, it's very easy to find the real power. So because can we find the current easily enough? Sure. It's just going to be the current is just going to be the voltage divided by the impedance, which here is just a resistor. So 3.2 angle 150 over 1. So you're using a calculator to divide by 1? I know. So that's 3.2 angle 150. And so our complex power is 3.2 angle 150 times 3.2 angle negative 150 times 1/2. So can someone tell me the 150 and the negative 150 will cancel each other out, which makes sense? Why does that make sense? Because it's just a resistor, it's all real. So we would expect to get all real power. So 3.2 times 3.2, I could reach for my calculator. 5.12.
Are you rounding using Johnson or something?
5.12, and our units would be VA. Now, it does not have an imaginary part, and so if we think about it in terms of P plus JQ, our P
is all of it.
I forgot the 6. This is 3.26.
I thought you perfect.
No, I did not do that.
No, because the rounding would probably.
So I think you're right. So what did you get?
Me?
Yes,
5.31.
that's it. Yeah, because I forgot the 6.
5.314.
5.314 VA. And so that's 5.314 plus J0. And so our reactance is 0, but our real power is 5.314 watts.
These units are the
Now we need to get the voltage of the load. So we can do that with nodal analysis, but we know what VL is, so that helps us. So VL is 3.26 angle 150 degrees. So at V1, I would say V1 minus 4 over. I'm gonna move this up, but you won't be able to see the circuit diagram. So V1 minus 4 over J100 minus 2 angle 0 plus V1 minus. Now notice I'm not actually finding VL, and I'll explain that in a minute. V1 minus 3.2 angle 150 over 1 minus, now I need to figure out what that 2 microfarads is in phasors. So a capacitor has ZC equals minus J over omega C. So this is minus J over omega. We get that from our voltage up here, which is 10 to the 4th pi. So you find omega in the as the coefficient of t. Yes.
V1 minus 4 angle 0 over J10.
J10. Thank you. So this was minus J over omega, which was 10 to the 4th pi, times C, which was 2 times 10 to the negative 6. So this is minus J over 2 times pi times 10 to the negative 2, or minus J over 0.02 pi. That's as far as I can go without a calculator. So someone needs to tell me what 1 over 0.02 pi is. It would be 50 pi. What is it? Yeah.
55. Or 50.
No, it's 50. It's 50 over pi. 15.9. So minus J 15.9 ohms. Yes.
So for the method that we're doing, since the current source is facing away, would it be
It would be adding. That's why I needed to have y'all all here. Yep. In my head, it was going towards. Because I drew it wrong. I drew it wrong. That my answer, the problem that I was copying it from, has it going this way. So if I want to check the answer, I need to have it going that way. I don't know if I like that. Minus J 15.9. So this is 1 minus J 15.9. So let me rewrite that whole nodal equation again neatly. So I have V1 minus 4 over J10. And then we
And then we
decided it would be
minus
minus 2
2
because I turned the current source around. Plus
plus
V1 minus
minus
3.26 angle 150
150
over
over
1 minus J 15.9
15.9
equals 0.
equals 0.
Now, the
Now,
way
the
I
way
solve this is I want to do as little math
math
as
as
possible.
possible.
So
So
I'm going to break up
break
these
up
fractions.
these fractions.
So I broke up the fractions so
so
that I could get everything with V on one side and everything without V on the other side. And so that way I can factor stuff out. So on this one side, I will have V1 times 1 over J10 plus 1 over 1 minus J15.9. And on the other side, I will have 4 over J10 plus 2 plus 3.26 angle 150 over 1 minus J 15.9. At which point, honestly, if I'm taking this test, I stop here and I just move on and go on to the rest of the test because there's no way I'm going to get this right. There's too much, and then I'll come back and do it if I have time and I'll get the number. So I need y'all who are capable of using calculators to tell me what this value is in the parentheses and what we have on the other side of the equal sign. And I need someone to tell me if I've made any mistakes so far. I'll do it.
Fine.
No, it's just I just don't have any faith in myself. I mean, I've never been great at arithmetic, even when I was little, but I've just gotten really
I
bad.
took the calculator class actually.
On the right side, ooh, that's enough. Yeah, it was probably paid for, but that was something.
Oh no, they had like 100 Inspires.
Yeah.
That's interesting.
So on the right side, I got 1.97 as negative 16.8.
1.97 and the angle negative 16.8.
Yes, on the right
Okay,
side.
if anybody else gets that, if anybody else gets either of these things, I would like a verification, and I left out my V.
And on the left side, I got 1 times 37.6 times 10 to the negative 3.
Oh, yeah. And your angle.
I have a final, but I don't have the intermediate. An angle of negative 83.9. I have 84. I got very close to that, but it might have been a rounding thing.
Probably around
What was the magnitude you got?
Second,
he got
Was it 7.9?
negative 83.97. I get 52.44. No.
I got 52.47 and with the angle to 67.15.
That's what I just got. Yeah. So 52, we'll just say 52 angle 67. Now, that is not the answer to the question because the question asked for VL. We found V1. How is that not VL?
You're practicing from 4, not
Right. Because my ground is here. So right here is 4. So VL is 4 minus V1. VL is 4 minus V1.
I was wrong.
which
which
is
is,
So is that what you got? Is that what you got? Okay, dope.
which
which
is
is
51 angle negative
negative
108.7,
108.7,
which
which
has
has
rectangular. What did you get it to be as rectangular? Well, I don't actually need it as rectangular because what does the
what does
problem
the problem
actually
actually
ask for?
ask for?
VL of
VL of
VL of
t.
t.
VL of t. So now I need to say it's 51 cosine
cosine
10 to
10
the
to the
fourth
fourth
pi
pi
t minus
minus
108.7
108.7
degrees
degrees
volts.
volts.
Sorry, the chair's a little.
I know, I'm
I know,
sorry.
I'm sorry.
No, it's
I-
okay.
yeah.
What is like omega t e to the Oh, right.
All right.
All right.
And
Do we not need
well,
the
it's
other
supposed
half
to
of
be
the roads one after that, or? Because there is an imaginary component.
yeah,
it's
no,
no,
we don't because when we say VL of
VL
t, we want the real. This is the real
this is the
part.
real part.
So
So
the real part is most.
most
I'd venture to say that most electrical engineering students don't know this, and probably I don't know
I don't know
if people really understand this or not. Because we use complex numbers all the time. We actually are using them as tools to get the real part out. So so quantum mechanics, that's using imaginary numbers, and as far as I know, there's no way around it. You can do all of this with just real numbers. You think this is hard. It would just be a real pain.
Oh, yeah.
So by sending it into the complex numbers, it makes it a lot easier to work with, and at the end we pull the real part out. But anyway, yeah. Okay. That doesn't mean the complex part doesn't tell us something, because it does. I mean, it's all very important. I'm just saying it's not. You could do this without involving complex numbers.
Okay.
Does that make any sense? Okay, yeah. It would be very hard, but you could. You could do all of this in other sorts of ways.
You could say it would be more complex.
You could. Right. Okay. So all right. So now we want to determine the complex power of the voltage source. And so if we look at our voltage source, we know the voltage across the voltage source, of course. Let's see. So do we have the current across the voltage source? Easy enough to find. If I look at the current across this inductor right here, that current, the current is always the voltage where you start minus the voltage where you end over the impedance in between. And so the current across the inductor is 4 minus 51 angle negative. Oh, actually, don't we already know it? Because didn't we just find this going the other way? 108.7. Yeah. I'm on to part C. Over. What's that? Okay. I'm not saying. I don't. Like I said, I haven't worked this in years. So the current is 4 minus 51 angle negative 108.7 divided by J10. which is
which is
5.2 angle negative 22.8. It might not be. That's what I got. Did anybody else get that?
I got the same magnitude, different angle. I got 5.1 angle of 161.
161.
Yeah.
So what happens
What do we do with
an
that?
angle that's real?
You know, do you know the rule?
Yeah,
the
the
rule-
rule
Oh,
180.
oh wait, never mind. Never mind. Yeah.
All right.
You confuse me, and then I
That
confuse
still
myself.
is like a large angle.
I got the same thing as
The whole
Rebecca.
180, so it checks out.
I think of the same thing as Rebecca.
I'm still
I'm
getting
still getting
negative
negative
22.8.
22.8.
Granted, I did it by Ohms.
I'm gonna try it again.
I'm using
I'm
Ohm's
using
law.
Ohm's law.
That's it. You did the VL we count on the last part over JSON.
VL over what?
Over what?
That's it. VL over JSON.
It would
It
not
would
be
not
VL
be
over
VL over
J10.
J10.
Okay,
Okay,
why is it not VL over J10? This is like number one issue
issue
with
with
circuits is wanting to just use Ohm's law and saying it's V over Z or V over R. It can't just be V over R because it has to be the change in the voltage over the impedance. So it has to be, and I want it going, well, I have it going in the wrong direction, don't I? I want it, no, that's good, I want it going this way. Because I want the complex power, so that's fine. So, so I have the current going that way. So, and I got 52 angle 22.8. So the complex power of the voltage source is the voltage of the voltage source, which is 4, times the conjugate of the current, which is 52 angle 22.8. So the complex power would be 208 angle 22.8 VA.
Close enough. Sorry, 2.8, not
2.8.
Or sorry, 20.
I forgot my one half. Nobody reminded me about my one half.
You forgot your one.
Most people are not paying attention. It's really hard to feel. So I get 10.4 angle 22.8 is not the angle here of my answer. I'll double check that and see.
In your first S equation, I think you forgot a decimal point in front of the 2. For the 1/2, 4 times, it says 52 angle.
Yeah, it's supposed to be
22.8.
5.2. I think they corrected me here.
Okay.
And I think this would be 20.8, and then it ends up to be 10.
Yeah.
But that, I don't think that should have messed up my angle. Did everybody else get negative 22.8 for the angle for the current?
Yeah.
No?
Yeah. But it was
Right.
Actual electrons. Well, no, just down to a big total current. Electronics lab insurance have to be bit. The current is the whichever one's the first begins.
We found
The
this current,
current, which means that current is that current.
Yes.
Which else is the power?
Okay, so I'm going to stop this recording and move back to the other computer and do the next problem. What time is it? 6 o'clock?
It is 6.
Okay.
It was like 132. It was negative 85.9.
No, it was 10.4 angle 22.8. I had my decimal in the wrong place. So I had the complex power was 1/2.
Oh, no. Oh, no, I see.
Okay.
Okay.
Poetry, we're doing the voltage of the source and voltage.
VL, which is the correct voltage to use. I was confusing V1 and VL. So I thought I was using V1, but I was using the value. I was using VL, and since we had VL, we could have just done. So nobody here is the people sitting next to me are listening. Nobody else in the room is listening. So on that last problem, I thought I was using V1, so I did 4 minus V1 over J10. But I actually was using the value of VL. But since I had the value of VL, I already had the value of the change of the voltage across the inductor. I could in fact just use VL over J10. And when you did that, what did you get?
I didn't work into that.
Oh,
You told me I was wrong.
Oh, well, you were not wrong. You were right, and I was wrong. And so it should have been 51 angle negative 108.7 divided by J10, and that's 5.1 angle 161.3. And so then when you find the power, you take the conjugate of that. So you take 1/2 times 4 times 5.1 angle negative 161.3. And that gets you 10.2, and then 10.2 angle
161.3.
which I still think is not the answer on that sheet.
It was like 10.2 with the angle different.
10.19, 18.67.
Which is 180 minus 161.
Which is when you add 180. When you add
Somebody
no.
either I forgot the conjugate or he forgot the conjugate or something.
At some point.
Well, when you
I definitely use the conjugate calculator.
Well, there it is.
yeah, because if you add 180 to yours.